Good afternoon, everybody. Thank you for joining us. I'm sure there'll be a few more people that come in after we start, but that's okay. Nice to see your smiling faces. For those of you who don't know this, back in 2007, there were quite a few scientists out there in the world that were talking about the major declines of amphibian populations. And we at the zoo and many other zoos across the nation and aquariums decided that they were going to help with this amphibian crisis. And one of the ways, we didn't have a really large herp collection, which are reptiles and amphibians. What you see today in the Discovery Barn was directly from that. So we could start talking about the reasons for declines in amphibian populations. So that's what we did on grounds, but we also decided that we were going to be involved with conservation out in the field too. And we looked at programs that we could potentially be involved with, and one that just seemed to fit perfectly for us was joining the Wyoming Toad SSP. There were a lot of other facilities that were Midwest oriented and were pretty close to the Wyoming area. So we joined in 2008. And our role in this partnership between U.S. Fish and Wildlife, the SSP holds a captive population where we breed those animals and we send those animals' offspring back to Wyoming, and U.S. Fish and Wildlife recovery team decides on where they go and how they'll be put back. So there's a great relationship between AZA and the U.S. Fish and Wildlife. Doug Keinath, who was so kind to volunteer to not only come and speak today, but also at tomorrow night's board meeting, has been involved with this program for a long time. You can see up on the board his present position with U.S. Fish and Wildlife, but his progress with the toad has gone back 2 decades, 15 years plus. Doug originally reigns from Saginaw, Michigan, went to the University of Michigan for his undergraduate degree. Oh, okay. There's no booze out there from Ohio State fans, so that's good. Doug, we did talk about that last night, and he's not concerned about that rivalry at all. He graduated with a degree in engineering and natural resource management, which took him after college to Washington, D.C., where he worked on environmental climate consulting for 4 years. He said there wasn't really a love there, so it took him about 4 years to decide that he wanted to get back out into the field. And he worked with a professor up at the University of Wyoming on a master's program after that. So he moved up to Wyoming, started working on that master's program, and at the same time, he took a position for WIND, which is Wyoming Natural Diversity Database. So he's working on his master's degree and doing that for master's degree didn't take 15 years, but 15 years for Wyoming Natural Diversity Database, which got him involved with toads and many other animals in Wyoming after that. And then he also got his PhD, and then in 2016 he took the step further. There was an opening with U.S. Fish and Wildlife, and he decided, hey, I'm gonna take this on. He's done a lot of great things for toads in general, but a lot of the populations around Wyoming. So I appreciate him coming here. I think he's going to get the toads to the point, he and many other people are going to get the toads to the point where they can come off that endangered species list. Hopefully it'll be in our lifetimes. But I welcome Doug. Hope you all enjoy his talk. And you CAPS kids, remember, you have lots of questions at the end, right? At least one of you. Thank you.
Turn that one. There, you can still hear, right? Okay, cool. This isn't my typical venue, so I'm going to do my best. I'm not used to presenting in front of an IMAX screen. But I'm going to tell you a little bit about the Wyoming toad and what we're doing, the history behind it, what happened to it, and what we're doing to get it back into the wild. So the entire range of the Wyoming toad is encompassed by that red dot, which is in southeast Wyoming, the Laramie Basin. The entire global distribution of the Wyoming toad occurs within about 30 miles of the town of Laramie, Wyoming, which also happens to be where I live. If you zoom in on the Laramie Basin, what you see is there are two main rivers that come through, the Little Laramie River and the Big Laramie River, and they meet up and they flow off into the Platte. And that what's in brown right there is what we consider to be the entire historic range of the Wyoming toad. Oops, thought I had one more slide there. Anyway, and what happened? What happened? Why did this toad become endangered? In the 60s and 70s, it was considered very, very abundant in the basin. There are anecdotal stories of ranchers in the area who would get up in the morning and dump toads out of their muck boots before they went about their daily routines. So no one really paid much attention to it. It was one of those things that was just always around. And in the late 1970s, there was a precipitous decline, and no one really even noticed it was happening until a professor, George Baxter, who the toad is now named after, Anaxaurus baxteri, took a visiting professor out to one of the spots that he always saw toads, because the visiting professor was a herpetologist and wanted to see a Wyoming toad. And he went out to his honey hole and he couldn't find any toads. And that started 2 years of frantically going around the basin and looking for toads and not finding them anywhere. So and that led to its eventual listing as an endangered species in 1984. But by 1985, it was presumed extinct. We couldn't find any toads in the wild, and we thought we had lost them all. And then a couple years later, it was rediscovered at Mortenson Lake, which was at that time a private fishing lake. It was privately owned. But we went out there repeatedly, and that population was also found to be in marked decline. After a year and a half of monitoring it, the population was halving every time they went out to go see it. And so people were really stressed out that we were going to really lose it this time. They'd already lost it once. We don't want to lose it again. And so the decision was made after much soul searching in the late 1980s to take what we think are the last remaining approximately 16 toads into captivity. And that started what we now have as the captive zoo program. And then the timeline for this is all down there. So you can see there are, and after we did that, we kind of thought that the toad was again extinct in the wild. So it kind of went through, you can almost think of it as two extinctions. So if you think about that, it went from being abundant to endangered to extinct to only existing in captivity, all in the space of about 10 years. And that creates some real challenges for getting this critter back on the landscape. For example, what really caused the decline? I mean, it was gone before we even knew it was really declining. What kind of habitat did it use? No one even gave it any thought, right? It was just everywhere. What does its habitat really need? Genetics. That's a huge genetic bottleneck to go from, so abundant that you can't count them down to 16 animals. And then now that we have them just in captivity, animals adapt to captivity, and are they even suitable for going back out into the wild? So there's some real challenges associated with this species. And it becomes even more so when you think about what the causes of the decline were. So here are all the causes of decline. Those two with red dots by them are what we think is the most important. Probably any of you who have any association with amphibians know chytrid fungus. It is a disease that originated, originated in Southeast Asia that we think was transported by humans to the Western Hemisphere and has caused all those red dots, amphibian declines throughout the Western Hemisphere. And in fact, had it been appropriately identified back in the early 80s, it was originally, we knew that there was something affecting the toads, We thought it was ranavirus at that time, but had it been appropriately identified at that time, it would have been the first documented decline of amphibian species due to chytrid fungus in the US. So that is the big driver, we think. A second driver I'll get into in a little bit, which is hydrology, floodplain habitat loss, and I'll explain that a little more in a minute. But also there are some water quality issues, the use of widespread use of insecticides, particularly malathion in the basin, and changing weather events, primarily later colder springs with droughts intermittent. So these latter three we think are minor contributors, and particularly things like pesticides are much more regulated now. So it's really those first two that are the big problems. So floodplain in the Big and Little Laramie rivers. This is a picture of what the Laramie, one of the Big Laramie River back in the late 1950s. And what you'll notice is it's a very tortuous, braided prairie stream, and all of this stuff out here is floodplain oxbows, where the river channel used to be. And we think that the toad developed in these habitats where each spring this river would flood its banks and basically fill all of those oxbow ponds. It would draw down, and there would be all of these little oxbow ponds that are nice warm breeding habitat for toads. Well, cue humans coming into the basin and channelizing the river and irrigating meadows, and all of a sudden, this doesn't flood every year anymore. And so we got rid of a bunch of habitat and superimposed that upon, the chytrid disease, and I think that was probably the death knell. And one other thing that I'll point out here, if you see aerial photos of a lot of the Laramie area, you see that speckled, stippled pattern there on the highlands. Those are mima mounds. Not big evident mima mounds like you see in Washington, but just little low hillocks. And we think that is where toads mostly hibernated, is in that kind of habitat. So that's a typical shot from back in the day. Mortenson Lake, where we found the toads last, looks nothing like that. It is a lake that they used as a trout fishery. But when you look closer, you'll see that it has a variety of shallow wetlandy areas that mimic floodplain habitat. And it is surrounded by mima mounds that are riddled with small mammal burrows, which is where we have anecdotal evidence that the toads are hibernating. So it just so happens that we lucked out that this privately owned and protected lake mimicked toad habitat, and there's nothing special about it other than that it mimicked their natural floodplain habitat. So how do we get this toad from that one lake back into the environment? And the key, one of the big keys, is the captive population, and which is Kansas City Zoo is one of the facilities, as Sean said, that breeds Wyoming toads for us. And what that does is it keeps the toad extant. It keeps it from going extinct. It preserves the genetic diversity as much as we can, and it generates offspring that we can reintroduce into the wild. The second step is reintroduction. We put those toads back into the wild and mitigate the threats to the extent that we can. The third step is we research and understand what we're doing works and what we're doing that does not work. And then adaptive management, we have to take that research knowledge and act on what works. So improve on what works and don't be afraid to let go of what doesn't work, even though we've done it for years and years and years. And the last thing is build partnerships. Recovering an endangered species is such a big job, no one can do it alone. We need the zoos, we need the Fish and Wildlife Service, we need the Wyoming Game and Fish Department, we need buy-in from local landowners, we need the Laramie community to become involved. Everyone has to get involved to conserve this species. So I'm going to step through each of those just really quickly and let you know what's going on. The captive population for Wyoming toad now consists of 8 zoos and 3 Fish and Wildlife Service facilities that breed these toads specifically for reintroduction. And I'll talk about these more later when I get into the data, but it's just a phenomenal effort that the zoos do. We could not have gotten as far as we've done without them. I mean, they would have been extinct had Fish and Wildlife Service and the zoos not figured out how to keep those 16 toads alive and breed them. I mean, it would be gone, and we wouldn't even be at the point of thinking about where we can put them back into the wild. This is what I just said. They're the key to recovery. This is a graph, and we'll get back into this more later, of since 2005 or so, which is when the captive zoo program really kicked off, of reintroductions. And so you see that, oops, again, wrong button. Again, in the past, several years, things have really kicked up. So our numbers have increased. We're reintroducing a lot more tadpoles, but even more so, we're increasing our introduction of adults. And this has had huge dividends, which I'll show you in a minute. So where are we putting them? Mortensen Lake, this is back to that map of the Wyoming Toad Range. That right there is Mortensen Lake. Mortensen Lake was privately owned. It is now the local landowner, and this is again goes back to building partnerships, agreed to sell his land, and it went to the Nature Conservancy, who then donated it to the Fish and Wildlife Service to start a refuge specifically for the Wyoming toad. So that is just one spot in the historic range. We can't recover the species in just one spot. And so the idea is to search out this range and find other areas that seem to be suitable for Wyoming toad. Currently, all the ones in blue are what we have as active sites. These two here are private. One is owned by a foundation based out of Omaha. Another one is a private landowner. This one over here is actually owned by the city of Laramie. It's actually right outside Laramie, and that was our most recent addition. We have an inactive site that's owned by the University of Wyoming, and we're hoping to bring on another one probably next year or the year after that is a state section, and it will involve the State of Wyoming State Lands Department. Our overall goal is to continue to move forward into the heart of Wyoming Toad Range. All of our stuff so far has been sort of just by happenstance on the south, and we really need, in my mind, to get back up into what floodplain habitats remain on the confluence of the Big and Little Laramie rivers. And this is a huge, in bringing on each one of these, because this basin is mostly privately owned. So every site that we get out there is an independent agreement with a private landowner to let us put an endangered species on their property, which is not a trivial endeavor. So our reintroduction priorities are first figuring out how to release. And in order to do that, we need to clarify what habitat the toads actually need. We need to find the right mix of life stages. So you saw in that graph, we released tadpoles, toadlets, and adults. We have to figure out a strategy to keep them alive in the wild. And the pictures here are soft released enclosures. These enclosures here on the left are Head Start tanks or enclosures for tadpoles. And here are similar things for adults. And we keep them in there, they keep the tadpoles in there until they metamorphose, and that is to prevent the mass mortality which is generally associated with transition from tadpoles to juvenile. And for adults, we just keep them in there for just a couple of days, just to get them acclimated to the wild environment. Again, these critters have never seen the wild, and so they wouldn't know what to do if a skunk came along and tried to eat them. We just need to protect them just for a little bit. And then we monitor. We have to keep track of what's going on out there, where the toads are, how they're doing, if they seem to be surviving. And chytrid fungus. Chytrid fungus is a really, really hard one to deal with because it's everywhere in the environment, and we know that the toads are highly susceptible to it. And so the key here is to get breeding. We want to promote wild breeding so that we encourage the toads to adapt themselves out of this problem. And I'll go over that a little more in a little bit. Get more release sites with more diversity of habitat. Because we don't know what their preferred habitat is. And it may be Mortensen was just a one-off and we were lucky to get it. And we need to get more different habitat out there and see what works. So now the research component of it. We have facilitated many research projects over the years to figure out what's happening with the Wyoming toad. The most recent just started this summer. And now that we have those large release numbers that I just showed you, we need to figure out what is happening to all those toads. We monitor and we count them, and we haven't been finding as many as we thought. And so this PhD student, Rachel, just started this summer at the University of Wyoming to assess the factors that influence the survival of all these reintroduced toads. So over the next couple of years, she's going to track a couple hundred of these toads with radio transmitters similar to this one right here on a Wyoming toad that we released this summer. And it presents the setup that we have with all of these adult toads that are being released that are individually identified. They all have bit tags, radio chips in them, is that we can link, hopefully in one analysis, all the different things that are affecting Wyoming toads. So each of these toads, they come from a different genetic lineage, and that could impact their resistance to BD. They exhibit different behaviors. Even in one summer already, we've seen that some toads move a lot. Others don't move hardly at all. Some spend their time out in the open. A lot of them spend their time under root masses or whatever. That behavior, their ability to shed the disease, can influence and by BD here, if you don't know, that's the initials for the scientific name of chytrid fungus. So that's chytrid fungus. Habitat, the type of habitat influences how prevalent BD is in the environment. The site type, is it a river site, is it a lake site, could influence the prevalence of BD in the environment. So all these things we can now track with all these different toads and see how that affects their survival. In addition to that, we can see how the soft releases are working. Do these toads that we soft release survive more than toads that we don't soft release? The other big bottleneck that this study will hopefully help us understand is hibernation. After decades of doing this, we do not have a good sense yet of how these toads overwinter. And I personally expect that one of the big bottlenecks to get these captive toads into the wild is successful hibernation sites. And they might not be able to do it. They may just not have the knowledge or the instinct to do it, but we'll see. So this is a big research project that's going on right now, and will hopefully, it will help us choose the right habitats to start reintroducing them into. It will choose the right sites, and it will help us, hopefully, maybe the zoos learn how to, if we can identify genetic markers that predispose toads to being resistant to chytrid fungus, we can enhance our breeding efforts as well. So, is there hope with all of the hard stuff that I've been telling you? Is there hope that we can actually recover this species? This is survey counts of Wyoming toads since it was discovered. So the very first point on this graph back here in '87 is when they were rediscovered at Mortensen after we thought they were extinct. And we've done annual counts since then. And you see that initial population was initially doing okay, and then it rapidly tanked. And then in here is where we thought it was extinct again. And what you see here is that we're doing better in the last 5 years or so. Things have definitely gone up. There's fluctuations, and we're on a down cycle right now, and I'll talk about why that might be. I'll superimpose on this graph now. The blue bars, if you can see them, are numbers of toads released into the environment, and they're adult equivalents. So I downgraded, it's 20 to 1, so one tadpole is equivalent to one adult in this graph, but just to simplify it. And what you can see, I'll point out some things. So the first new reintroduction sites occurred just after 2005. So this whole time frame in here, we were just doing stuff at Mortensen. We started doing some of those other sites on board in this time frame in here. You'll notice right here that these blue bars take a marked jump up, and they're much higher in this period than they were in this whole history of the Wyoming toad. We began all that soft release stuff with head starting them in those enclosures around 2013, 2014. And we began reintroducing adults along with the tadpoles in 2015. And so these cumulative efforts, in my mind, are what is helping us maintain this higher population level overall here than over here. And if we continue this trajectory, I'm hoping that we can get our way out of the spiral that the toad has been in for years. But what's even more important than that, what I've now superimposed on this graph in the yellow bars are the documented breeding events that we've noticed in the wild when we've been out there. And you'll notice that, you know, back when Mortensen was doing on its own okay, there were quite a few breeding events. But then pretty much from the early 90s through 2015, there was no consistent breeding in the wild. I mean, pretty much there was a decade and a half here where you had only 5 breeding events ever for Wyoming toad. And now look at what's happening since 2015. We now have consistent annual breeding across multiple sites, which we haven't had since about 1990, which is, in my mind, even more so than the population numbers, the most hopeful evidence that we might be working our way out of this problem, that these toads are actually finding a way to breed again in the wild. Yes, exclamation point, wild breeding. So what's causing all those numbers to bounce around, that fluctuation in population? And that is chytrid fungus, I think. If you look at this graph, it is, on the axis here, is proportion of toads that we find that are, when we do our surveys, that are infected with chytrid fungus. Since we've been doing it, we started tracking chytrid fungus back in 2007 or so on a regular basis. And I'll point out a couple of things from this graph. One is that we have this cyclic pattern kind of going on, especially recently. And if you superimpose the counts that I just showed you on that, you can see that after the chytrid fungus gets up to a certain level, we have a population crash afterwards. And in fact, that's a really highly significant relationship. So on this graph, the number of toads infected is down here, and the change in toad counts in the subsequent year is here. So when we have a chytrid rate of 0.6%, we're likely to, or 0.6, so 60%, we're likely that the next year is going to be a declining year. So that seems to be kind of the critical level, right? If you get a chytrid rate in any given year above about there, you're really highly likely you're going to have a population crash in the second year. So chytrid, I think, is driving those population dynamics. However, if we go back to this graph, 0.6 is right there. And what you can see is, in my mind, and this is my interpretation, is back here, you have chytrid rates. The percentage was very, very frequently above 5 or 6, right? 5 or 50 or 60%, and has kept the population low. But now we're getting into this pattern where we have a lot of years that are lower and the peaks aren't necessarily getting quite as high. And one way to interpret that is that we're getting more chytrid resistance out on the landscape. So one way to interpret it. And this is not unique to Wyoming toads. So there are examples of other amphibians throughout the world now that, like this example from mountain yellow-legged frog, that other species are able to persist in the environment, have been shown to adapt after the initial declines. And the mountain yellow-legged frog, is one example. I mean, chytrid caused its populations to crash heavily. And then after a decade or so of being in the wild, populations increased, not to the levels that they were before, but they increased and have remained relatively stable since then. The difference between yellow-legged frog and toad is that the yellow-legged frog never went to the point of extinction. It just declined and it kept breeding in the wild. So if you go back to our graphs, you can kind of pretend that right in here is sort of where we were at the early part of the in the mountain yellow-legged graph, because that's where we are just getting wild breeding. So my hope is that this overall trend is a trend that persists, and we get chytrid levels that are lower over time and population levels that are continuing to go up. They're going to keep crashing when we get high levels, but hopefully those crashes will be lower and will never preclude wild breeding in the future. So yes, there is hope. And the final thoughts that I'll leave you with are that I believe recovery is possible, but it depends on captive reintroductions, continued captive reintroductions, so continued input from the zoos and the SSP community. It depends on diligent field efforts on our part in the Fish and Wildlife Service to keep these toads on the ground, to make relationships with landowners and keep new sites coming along, and it needs time. This is not a species that we're going to recover most likely in the next decade. Maybe it's decades out. Hard to tell with disease, but we need time to do it, but I think it's possible. And with that, I can take any questions. Yes?
You know why the chytrid disease levels fluctuate?
Do I know why the chytrid disease levels fluctuate? We don't know for sure. We expect that it has something to do with weather patterns. Other amphibians have been shown to be able to shed the chytrid fungus to some extent if they can bask more. And so these longer, cooler springs that I mentioned, when they come out of hibernation and they're stressed and they can't, and it's cool and they can't bask and shed themselves the fungus, that might be a bottleneck for them. The other thing is carriers in the environment. It might be that you need a certain number of toads and chorus frogs and other amphibians out there in the environment to make the reservoir large enough to the point where it gets to affect toads. There's a variety of reasons. Those are the two most prominent, I think. Yes?
Possibility of like a worry that they're going to inbreed at all, or like certain genetic like disorders or diseases would come through?
That is absolutely a concern whenever there's such a bottleneck in the captive population. We know we have inbreeding. We are actually right now, we have to manage that. We can't cure it. We can't reintroduce new genetic stock, and so we deal with that by optimizing our breeding to minimize our loss of genetic diversity, but that is absolutely a problem. And is also another reason why our main strategy is to get them out there breeding in the wild so they can start to adapt on their own. Yeah. Sorry, say again?
It will always be a disadvantage for the toad.
Inbreeding will always be a disadvantage for the toads? Is that what you're... Oh, chytrid fungus. Yes, that'll always be a disadvantage. Chytrid fungus, the question was, will chytrid fungus always be a disadvantage for the toads? And yes, it'll always be a disadvantage for the toads, I think. But if we get enough adaptation in the wild to promote resistance in the captive population, or in the wild population, I think it's something that they can recover from. They're probably not ever going to be abundant again, but we can improve on it. Yes.
Thought of a way to like, if the toad has the disease, have you ever like thought of a way to like cure it from them?
Yes, you can. In captivity, you can treat the toad with an antifungal agent, and it will get rid of the chytrid fungus on that toad. The problem is we can't do that in the wild in any meaningful way. So we treat the captive population, but we have to figure out a different strategy for the wild. Yes.
I wanted to know how the chytrid fungus affects, like what it does that increases the population of like how it kills.
So how does the chytrid fungus decrease the population of the toads? How does it kill them? And I should have described that better back here. Let me get to that again. Yep, there we go. So the chytrid fungus, this is a micrograph of the skin of a toad that's been infected by chytrid fungus. And this is normal skin right down here. And this is skin that has been infected by the zoospores of the chytrid fungus, where the arrows are. So it gets into their skin, and it basically turns their, if you've seen an amphibian skin, it's soft and it's permeable, so they kind of breathe through their skin and they take in nutrients through their skin. So this makes their skin hard and fluffy, and it prevents them from doing that. So they can't breathe very well, and they can't take in nutrients through their skin anymore, and that causes them to die. Yes? Sorry, I keep saying you're in the shade. Oh, okay. Is there a way they can become immune to the disease? They can't, as far as we know, they can't become immune to it. If they get the disease, and then we are able to cure them of the disease, or they're able to shed it, just like kind of when you get chickenpox and you don't get chickenpox again, they might become more resistant to it. But if the chytrid gets bad enough out there, they can still be affected and they can still die from it. So full-on immunity, no. All right, I can get to you now. Yes. Sorry, there's hands raised up all around you. I keep missing you.
Say like you guys have no idea
We think chytrid fungus and that loss of habitat, floodplain habitat that I talked about. Those are the two big things. Yep. And antifungal. And actually, it's very similar to the fungal treatment that you use for athlete's foot. It's very similar. You bathe them in it, and it kills the chytrid fungus that's on the skin. Yes. Sorry, I keep forgetting it. Yeah, okay.
The decrease in their population, has it affected like a bunch of other species, or is it different?
The question is, has the decrease in their population affected other species? Is that right? We have noticed that there are other species in the Laramie Basin that have declined during the same time period that the toad declined. Leopard frogs are one of them. And we assume that that's related probably to the change in hydrology, the change in water in the area. We don't know if they're exactly linked, like one caused the other, but there are definitely other declines in the area and around the west that are very similar. And probably, yeah. It most likely, once we do that, it will be more resistant. So it might take a worse infection for it to be affected by it, but most likely it would be infected again if the chytrid in the environment was bad enough. Yeah. Yes.
Have you possible checking the diet of the toads, the chytrid fungus to be in the bugs or insects that they eat?
Could the chytrid fungus be in the diet of the toad, in the bugs or insects that it eats? Almost definitely. Insects don't get infected by chytrid fungus, but they almost definitely consume chytrid fungus. It's just everywhere in the environment, in the aquatic environments out there. It's pretty ubiquitous. Yeah. Yes, up there. Yes, sampling has remained fairly, the question was, has sampling remained consistent over all the time we've been out there? And throughout, so the sampling has been pretty consistent. So this whole period right here was just Mortensen. And this period was actually sampled a little bit more heavily than subsequently. They went out there during this period, 4, 5, 6 times a summer and did surveys. We thought after this last crash that it might have gone extinct in the wild again, and so this is back before I got really started with the program. They didn't do surveys there because they just thought, what's the point? So we restarted surveys there when I joined the program. And since then, we've been doing it in a very replicable, consistent way that is not quite as intense as back then, but is something we can maintain over a long time, over longer sites. So I think the numbers are roughly comparable, but there is definitely a break here where the methods are different here, but they're less intense over here. We're not out there in all conditions. I definitely think weather has a factor. The question was, does weather have a factor in the surveys and what we see? And we have some very tight, again, not in the past, it was all over the board, I think, in the past, but now we have some very rigorous guidelines. You know, we only do surveys between about 8 in the morning and 2 in the afternoon. We only do them with wind speeds, I don't know what the mile is, on the Beaufort scale, anything less than 3, and we only do it when there's no precipitation. So we try to make it fairly standardized, all of our survey types. So I think it's at least recently fairly standard. Yeah. Yes. There's not a lot of construction out there. It's a pretty open basin yet. The question was, have the other animals out there changed dramatically? Yeah, I mean, yes and no. This used to be a high plain with bison in it. There's no bison out there anymore, except for on ranches. Other amphibians have gone down. I think that there are currently, we're discovering things like bumblebees and things like that have crashed out there too, but that's happening all over the West. Otherwise, the fauna out there, the complement, the diversity is about what it was back in the day when the toads were doing all right. Like all the small, I don't know of any small mammals that have gone away. I don't know of any large carnivores. There's not grizzlies roaming around out there anymore, but I haven't noticed any other major decreases in blocks of other taxa. And most of those other things can be clearly pinned to things like grizzlies and stuff like that, to us pushing them out, as opposed to some environmental thing. Has the flora changed? I mean, the question was, has the flora changed out there? And I would say yes, because a lot of, when we were draining the river, the reason we were doing that was to plant hay fields and things. And so a lot of the native prairie, there's still a lot out there, but it's been supplemented with a lot of invasive grasses and things like that. So the overall type of habitat is similar, but the composition of the grassland is definitely different. Yes? The question was, were there Wyoming toads in captivity prior to taking the 16 in? And to my understanding, no, there was not. Yeah, so the question was, what are the predators and how do they factor into recovery? We don't have a good handle on what the predators are. We discovered a lot even just this summer though. And one of the primary predators we think is skunks. Because toads, I should maybe back up, like most toads, they sort of eke out their living by avoid predation by being unpalatable. They have very large, poisonous glands on the back that make them unpalatable to most critters. So most critters will, spit them out. Skunks will flip them over and take out the insides. So they can avoid the glands, and they're smart enough to do that. And one of the other major predators we think is corvids, so crows, ravens, magpies, things like that, that are also, they'll skin them essentially, because they'll just pull the skin off and eat what's left. So they avoid the glands that way. And then when they're tadpoles, lots of things eat them, like diving beetles, predaceous insects, mayflies, pelicans, and things like that can eat them. How does it factor into recovery? I think when they were abundant, it wasn't a problem. But the problem is now that we have such a low population, even one skunk that figures out how to get toads can work its way around a lake and just take out a bunch. And so it's more of a challenge now, which is why we do that's why we instituted the Head Start program. Yes? The question is, what numbers of toads and what numbers of toads would need to be in the wild in order for it to not be endangered? It's a very good question, and we don't have a hard exact number, but what we're looking for are 4 self-sustaining populations. So those dots that I had on the map, we want 4 of those dots to be self-sustaining, and I think the period is over like 5 or 7 years. And so regular wild breeding, without any reintroductions, they can maintain their population levels over that period of time. And if that happens, we can take it off the list. Yes? Is there a concern that chytrid fungus can spread to other animals? And I would say no. Other than other amphibians, I've never heard chytrid fungus being a problem for any other animal. It doesn't affect, because amphibians are really sensitive because of they breathe through their skin, and that's why it gets them. And they're the only entity out there, the only species out there that does that. Yes?
Is there like any way that a government could, like a program that could try to find the chytrid fungus and try to wipe, since it's not originally from the United States, but wipe it out?
Yeah, and is there a program out there that's trying to wipe out the chytrid fungus in the wild? To my knowledge, that is not even on the table, because it is just everywhere in the environment, and there is nothing that I know of that would be effective. And I don't know of anyone who's researching that. Like, I think it's a daunting problem. Yep, so I don't know of any. Yes? I work with, the question was, why did my organization choose to work on toads? And so I'm with the Fish and Wildlife Service in Wyoming, and this is the animal that's in our backyard, and so we did not want to let our local native animal go extinct. And so that's why we started working on it. What about the other stuff? We have people working on those as well. The bee situation is a much more recent problem that people all over the country are trying to get a handle on. Yeah. I'll move on and then I'll come back to you. Yes. What determines a good reintroduction site for the toads? That is also a very good question, and we're trying to get a handle on that. But what we think constitutes a good reintroduction site for the toads right now is something that is either in the floodplain or else mimics the floodplain of the Laramie River. So something that floods in the spring and gets shallow and warm midway through the summer. Also, we think that not a lot not trees. So they're in floodplains, they're in plains. The Laramie Basin is all willows and grassland, and so we think willow and grassland sites as well. But we're trying to figure that out kind of right now. Okay, I told you I'd get back to you, so we'll go to you and then we'll go to you. Will the Fish and Wildlife Service help other animals once the toad is off the endangered species list? Fish and Wildlife Service, and I should mention all of the zoos here, are working on lots of animals, and we are currently working on lots of animals. And the answer would be yes. We're trying to work on a lot of them now, and once we do recover the toad, we will shift some effort probably to other animals as well. But even after the toad, I should mention, gets off the endangered species list, we still have to keep an eye on it to make sure that something doesn't happen and pushes it back over into there. So we'll keep working on the toad even after we get her off the endangered species list. There's someone over here.
This will be our last question.
Okay. Do we find toads daily out there? Can you still come across them? It's hard. It's not like it was back in the day. But if you go out to one of the reintroduction sites during the middle of the summer and you walk around looking for toads, you will almost definitely find some toads. So you will come across them at the sites that we're putting them into for sure. But they're not common. You gotta look.
Okay, those were great questions, and luckily we had a lot of time for questions. Let's thank Doug again before I keep talking. That was very informative, and we've talked about toads before, but not in this extent. So thank you so much for doing that and visiting us. Doug will actually be speaking tomorrow night at the board meeting, our annual board meeting, in this room, and that's open to the public if anybody is interested in that. And then I was just going to thank you guys for coming. We are going to have another outside speaker for our next lecture series, and it's going to be a little different. It's going to be an evening event on November 14th, and that will be, we are going to have a guest speaker from the Marine Mammal Center speaking about all of their work with saving ocean species, both along the west coast of California and Hawaii. So please join us for that. We'd really like to see all of you there. And again, thanks for coming.